Hello, everyone, and thanks for joining this talk by Michael Kember. This is a very exciting talk by Econic, and he's joined us from Manchester. And Michael will be telling us about using waste carbon dioxide to make valuable polyurethane products more sustainable. Anyways, Michael, 15 minutes. As I just mentioned to you, 2 minutes before the end, I will intervene just to give you the heads up that you have 2 minutes. And yeah, the stage is yours. Please begin.
Thank you very much. So I'm here to tell you today a little bit about Econic-Technologies and our technology to transform waste CO2 into valuable polymer materials. I'm the head of research for Econic and also a co-founder of the company, which originally came from my PhD at Imperial College London quite a long time ago now. So I think we all know that we're emitting far too much carbon dioxide and that we need to do something about this if we're going to look after our planet for the future generations. But also in the medium term, a lot of the processes and products that our day-to-day life relies on involve carbon emissions. And therefore, we need to capture these emissions to prevent them going into the atmosphere. Now, carbon capture and storage is one route to doing this and can capture large volumes of CO2. However, carbon capture and storage only brings a cost. There's a cost to capture, there's a cost to store, and it doesn't create any value. It's therefore been relatively slow to adopt. Carbon capture and utilization, where you treat waste CO2 not as a waste, but as a valuable raw material that can make necessary products, is a much more attractive proposition because it gives you a value outlet for your CO2, which can actually pay for and incentivize the carbon capture. Now, our technology provides a catalyst and a process to turn CO2 that's captured from emissions and turn it into a polymer product that has a high value and is very useful for a number of different applications. Our technology is low energy, so it reduces the overall carbon emissions of the products, and it's a technology that's ready to go now to enable utilization of carbon dioxide today. So just to give a brief summary of the technology, a traditional polymer product will be made by using an oil-based raw material which is strung together in a chain, a polymer, as I've depicted with the oil drops on the top here. Our process replaces a portion of that oil-based raw material with captured waste CO2 depicted by the bubbles here. So that gives you a feedstock replacement of a waste CO2, which enables a reduction in the carbon footprint and therefore a more sustainable polymer to be produced. This technology can create a huge range of different types of polymers and different types of applications, but we're first targeting polyurethanes, which have application in coatings, which may be in footwear, or in automotive, or even in flooring protection, flexible foams, which could be the mattress that you sleep on or the chair you may be sitting on right now, rigid foams, insulation foams, which provide more energy efficient buildings, houses, refrigerators, or a wide variety of technical applications such as elastomers, adhesives, sealants, which may end up in your homes or in your footwear or a wide variety of applications. Furthermore, this technology can address a wider range of polymer products, which as a small startup company, we are not yet focusing on, but there's a lot of potential here. So our first two target markets are in polyols for polyurethanes and surfactants. Both of these technologies already use the raw materials that we replace today, and they are really quite substantial markets. We can adapt the existing process technology that is in the market today to use our technology to incorporate CO2 and to make modified products based upon the products that already exist today. We are really focusing on this technology adoption, and polyols is our first market. Surfactants, we have developed a technology that is a little bit further behind in development, but it's going to be coming through in the next few years. And beyond that, once we've commercialized our first opportunities, we will look at the much broader range of polymer products that can be made using this technology. So just to give you a summary on what the technology actually does, you replace a traditional catalyst technology that is available to make polyether polyols today. You replace a portion of the oil-based raw material, the epoxide drawn here, with CO2, and you incorporate CO2 into your polymer as a carbonate CO3 unit. So it's chemically bound within your polymer chain. And depending on your application, depends on the design of the molecule that you want. So for a polyol, you need to start with an alcohol that has 2 or more functional alcohol groups and can therefore react. The final product can react with the isocyanates it does today and create your final polyurethane products.